Today we are going to start new unit, that is unit 2. In this we have only one chapter, that is matrices and determinants. Okay. In this class we are going to learn the definition of a matrix, order of a matrix, next types of a matrices, trace of a matrix, equality of a matrices, and operations on matrices. Okay, if time permits, we will discuss operation on matrices. These are the topics we cover in this class. So first, definition of a matrix. A matrix is a rectangular array of numbers or functions. Numbers or functions arranged into rows and columns. The numbers or functions or numbers are arranged in rows and columns is called a matrix. Array means ordered collection. Rectangular array. Array means it is a ordered collection of numbers and functions which are arranged in the rows and columns. Rows and columns lo raste numbers ni లేదా functions ni, that formation is called a matrix. The numbers or functions listed in the matrix are called elements. ఏ నెంబర్స్ని అయితే రోస్లో కాలమ్స్లో రాస్తామో వాటిని ఏమంటాం? ఎలిమెంట్స్ ఆఫ్ ఏ మ్యాట్రిక్స్. ఓకే, అండ్ ద మ్యాట్రిసెస్ ఆర్ ఎన్క్లోజ్డ్ బై ఏ స్క్వేర్ బ్రాకెట్ ఆర్ పెరాంథసిస్ ఆర్ డబుల్ బార్ బ్రాకెట్స్. అంటే ఎలిమెంట్స్ రోస్ అండ్ కాలమ్స్లో రాసిన తర్వాత వీ కెన్ ఎన్క్లోజ్డ్ బై దట్ ఎలిమెంట్స్ బై స్క్వేర్ బ్రాకెట్స్ ఆర్ పెరాంథసిస్ ఆర్ double bar bracket, and matrices are denoted by capital letters A comma B comma C dashes. Okay, this is the matrix definition. Matrix is a rectangular array. Array means it is ordered collection of elements of numbers. Array of numbers or functions arranged into rows into columns. The numbers are arranged in rows and columns is called a matrix. And matrix, the elements which are listed in the matrix are called elements of a matrix, and the matrices are enclosed by square bracket or parenthesis or double bar brackets, and matrices are denoted by A comma capital letters A comma B comma C dash dash. Okay, now we can move to examples. For example, A equal to 1, 2, 3, 6, 7, 10. That is the matrix. In this, it is 1, 2, 3 is the row 1, first row R1, and 6, 7, 8 is the second row. Okay, and this 1, comma 6 is one first column, and 2, comma 7 is the second column, 3, comma 10 is the third column. Means we have total 2 rows and 3 columns. We arranged the elements in 2 rows and 3 columns and enclosed by the square brackets. That is a matrix, and it is denoted by the capital letter A. And next, in the second matrix, B equal to 4 minus 10 6 3 2 1 5 7 8. This is the first row R1, second row R2, third row R3. Next is this 4 3 5 is the first column, and minus 10 2 7 is the second column, 6 1 8 is the third column. Means 3 rows and 3 columns. 3 rows and 3 columns. Rows are counted from top to bottom. First row, second row, third row. And columns are from left to right, means first column, second column, third column. In this, first row, second row, and first column, second column, third column, means total 2 rows in the first matrix A, 2 rows and 3 columns. And second matrix, we have 3 rows, 1 2 3 and 3 columns, 1 2 3, 3 columns and 3 rows. Rows are counted from top to bottom and columns are from left to right. This is examples of a matrix. Elements are numbers are arranged in rows and columns is a matrix. Next, For example, A equal to 2, 4, 5 minus 6. Then number of rows and number of columns. We will count. This is the first row. This is second row. Means number of rows are 2. And this is the first column. This is second column. Columns are 2. Okay, rows are 2 and columns are 2. Next, second example. B equal to matrix 2, 3, 6, 7, 8, 9. This is the first row. This is second row. Means 2 rows. And columns, first column, second column, third column. So 3 columns. Next, third example. C equal to 3, 6 minus 8, 9 minus 2, 0, 6, 7, 5. So how many rows? First row, second row, third row. 3 rows. And how many columns? First column, second column, third column. Means 3 columns. Okay. In the first matrix, 2 rows, 2 columns. Second matrix, B matrix, 2 rows, 3 columns. And third matrix, 3 rows and 3 columns. Next. We will move to next examples. D equal to 1, 3, 4, 5. How many rows? Only 1 row. It contains only 1 row. How many columns? First column, second column, third column, fourth column. Total columns are 4. So D matrix contains rows 1. Number of rows is 1. Number of columns is 4. Next, E matrix 1, 2, 3. How many rows? 3 rows. And columns 1, 2. Means 2 columns. 3 rows and number of columns are 2. And F matrix, how many rows? First row, second row, third row. Means number of rows 3 and columns only 1. Okay, number of rows and columns. Rows are counted from top to bottom. Columns are from left to right. This is number of rows and number of columns in the matrix. Next, order of a matrix. What is the order of a matrix? If a matrix has m rows and n columns, if matrix contains m rows, number of rows m and columns is n, then m cross n, it is read as m cross n or m by n. Then ela chadavali? It can be read as m by n or m cross n is called order of a matrix. If a matrix has m rows and n columns, then m by n means m cross n or m by n is called order of a matrix. Example A equal to 1, 2, 3, 4. What is the order? 2 rows and 2 columns. So it is 2 by 2 matrix. And B matrix 1, 2, 3. 3 rows and 1 column. So 3 by 1, its order is a 3 by 1. And C matrix 1, 2. 2 rows and 1, 2, 3. 3 columns. So 2 by 3 is the order. And next, D matrix 1, 2, 3. 3 rows and 2 columns. So 3 by 2 is the order. Number of rows by number of columns. M cross n is order of a matrix. In the previous example, we see 6 examples. First one, what is the order of a 2 rows and 2 columns? Therefore, it is 2 by 2 matrix. And second example, 2 rows and 3 columns, so it is 2 by 3 matrix. And 3 rows here and 3 columns, therefore it is a 3 by 3 matrix. Okay. Next, here 1 row and 4 columns, therefore it is 1 by 4. Order of a matrix is 1 by 4. In this 3 rows and 2 columns, so it is 3 by 2 matrix. And here 3 rows and 1 column, so it is 3 by 1 matrix. Okay, order of the matrix is 3 by 1. Okay. Next, Order of a matrix is over number of rows cross number of columns. M cross n is called a order of a matrix. Okay. Next, structure of a matrix. How to write the general form in structure? If it is a 2 by 2 matrix, structure of a matrix, if it is a 2 by 2 matrix, means 4 elements, 2 rows and 2 columns, can be written as A11, A12, A21, A22, A11, A12, A21, A22. Suppose A11 means what it represents. A11 means the first number 1 represents row position and second number 1 represents column position, means the elements belongs to first row and first column. Suppose if you take A22 means second row second column, it belongs to second row second column. A21 means it is second row and first column. 21, first number represents row position, second number represents column position. Next, suppose if it is a 3 by 3 matrix, okay, then that is A11, A12, A13 means first row first column, first row second column, first row third column. Next, A21, A22, A23 and A31, A32, A33. It is a general. If it is suppose M by N matrix, M by N matrix means M rows, N columns, M rows and N columns. A11, A12, A13 dash A1N, A21, A22, A23 dash A2N dash AMN, AM2, AM1, AM2, AM3 dash AMN means first row, second row, third row, fourth row, M row. Next, columns is first column, second column, third column dash nth column. So M by N columns written like this, that is Aij M by N matrix. It is represented as Aij M by N, where I represents row position and J represents column position. Okay, I represents row position and J represents a column position. Next, the general representation. Next, types of a matrices. There are several types of matrices. First one, rectangular matrix, square matrix, row matrix, column matrix, null matrix or zero matrix, diagonal matrix and scalar matrix. Okay, rectangular matrix, square matrix, row matrix, column matrix, null matrix or zero matrix, diagonal matrix and scalar matrix. Next, unit matrix, lower triangular matrix or upper triangular matrix. We will discuss these definitions, types of matrices. Okay, first one, rectangular matrix, a matrix in which number of rows is not equal to number of columns. In a matrix in which the number of rows is not equal to number of columns is called a rectangular matrix. Number of rows not equal to number of columns is called a rectangular matrix. Rows not equal to columns. Suppose, for example, in this matrix 2, 4, 8 minus 4, 5, 0. It is 2 rows. We have 2 rows, 3 columns. 2 by 3 matrix means number of rows 2, number of columns they are not equal. Therefore, it is a rectangular matrix. And B example 2, 0, 7 minus 4, 5, 6. In this 3 rows and columns are 2. First row, second row, third row. First column, second column. So 2 columns. Therefore, rows and columns are not equal. Therefore, it is a rectangular matrix. Next, square matrix. Second one is a square matrix. A matrix in which the number of rows is equal to number of columns is called a square matrix. Means number of rows equal to number of columns, then it is called a square matrix. For example, A matrix 1, 2, 3, 4. Row 1, row 2, 2 rows, 2 column 1, column 2. 2 by 2 matrix, 2 rows and 2 columns. Number of rows equal to number of columns. Therefore, it is a square matrix. And in B matrix 4, 5, minus 6, 7, 2, 4, 3, 2, 0. This is first row, second row, third row, first column, second column, third column. Means number of rows 3, number of columns 3. Means it is 3 by 3 matrix. So equal. Therefore it is a square matrix. Number of rows equal to number of columns, then it is a square matrix. Means 2 by 2, 3 by 3, 4 by 4, 5 by 5, 5 cross 5, 6 cross 6, like that. All are square matrices. 1 by 1 also. Next. Row matrix. Third matrix is a row matrix. Row matrix means a matrix having only one row. A matrix which contains only one row is called a row matrix. For example, 2, 3. A equal to 3, that is, it has only one row and 2 columns, therefore 1 by 2, it is a row matrix. B equal to 1, 4, 5, 6. So 1 row and 4 columns, therefore it is a only one row, therefore it is a row matrix. Next, fourth one, a matrix, column matrix. A matrix having only one column is called a column matrix. Only one row unte, that is called a row matrix. Only one column, then the matrix is a column matrix. So here, first row, second row, third row, and only one column. 3 rows and one column, only one column, therefore it is a 3 column matrix. Here, first row, second row, third row, fourth row, 4 and only one column, therefore it is 4 by 1 matrix. It is also column matrix. Row matrix and column matrix. Next, null matrix or zero matrix. Null matrix or a zero matrix. If every element of a matrix is 0, then it is called a null matrix or a zero matrix. If every element of a matrix is 0, it is called null matrix or zero matrix, and it is denoted by O. Suppose O 2 by 2 matrix, means it is 2 by 2 matrix, all elements are 0, 0, 0, 0, 0. O 2 by 3 matrix 0, 0, 0, 0, 0, 0, means 2 by 3 matrix, all the elements are 0. A matrix which contains every element is 0 is called a zero matrix. Okay. Next. Note. In a square matrix, all the elements Aij in a square matrix means order of a matrix is 2 by 2, 3 by 3, 4 by 4, 5 by 4, 5 by 5, 6 by 6, like that. If a square matrix, all those elements Aij where I equal to j. I equal to j means A11, A22, A33 dash dash r are called principal diagonal elements or diagonal elements. But name antam diagonal elements are principal diagonal elements anta. For example, see in 2 by 2 matrix and in 3 by 3 matrix general form, it is a square matrix, it is also square matrix, that is A11, A22. These elements are called principal diagonal elements. In 3 by 3, A11, A22, A33 are called principal diagonal elements or diagonal elements. Okay. Let us see the examples. First example. 2, 4, 6, 0, minus 4, 7, 8, 7, 6. It is a 3 by 3 matrix, 3 rows and 3 columns. Therefore, it is a square matrix. In square matrix, A11, A22, A33. This is 2, minus 4, 6 are called principal diagonal elements or diagonal elements. Next example. A equal to 1, 2, 3, 1, 2, 3, 4. It is 2 by 2 square matrix. Here 1, 4, A11, A22 are the diagonal elements. that is 1 comma 4 are the diagonal elements or principal diagonal elements. Next one. The sum of the diagonal elements of a square matrix A is called trace of a matrix and it is denoted by a TR of A, trace of A. The sum of diagonal elements of a square matrix capital A is called trace of a matrix and it is denoted by a trace of A. Suppose A equal to 1, 4, 5, 6. What are the diagonal elements 1, comma 6? Their sum 1 plus 6 is called trace of A, that is 7 is trace of A. And second example, A equal to 1, 2, 4, 0, minus 7, 2, 0, 8, 9. So diagonal elements are 1, minus 7, 9. So trace of A equal to 1 plus minus 7 plus 9 means sum of the trace of elements. So 9 plus 1, 10, 10 minus 7, 3, therefore 3 is the trace of a matrix. The sum of principal diagonal elements is called a trace of element. Means trace of element is defined for only square matrices. Square matrices only have the diagonal, principal diagonal or diagonal, therefore their sum is means trace. Okay. Next type of matrices, diagonal matrix. First we see the rectangular matrix, next square matrix, row matrix, column matrix, now column matrix, zero matrix, now diagonal matrix. A square matrix, compulsory diagonal means it must be a square, means number of rows equal to number of columns, in which a square matrix in which all the elements are zeros except principal diagonal elements. Except principal diagonal elements, remaining elements are zero. If except principal diagonal elements, remaining all the elements are zeros, are called a diagonal matrix and it is denoted by diagonal of A11, A comma A22, comma A33. For example, 2, 0, 0, 0, 5, 0, 0, 0, minus 6 means a principal diagonal elements. Principal diagonal elements are not equal to 0, remaining elements are 0. It is a diagonal matrix and it is 2 by 2 matrix except principal diagonal, remaining elements are zeros, all are zeros, it is called a diagonal matrix. Okay, next. Scalar matrix. A square matrix in which diagonal elements are all equal. Diagonal elements are equal and all other elements are zeros. A square matrix in which diagonal elements are equal and all other elements are zeros are a scalar matrix. So 2 comma in the first example, diagonal elements are equal to 2, 2, 2, 2, remaining elements are 0, it is called a scalar matrix. And next B matrix 5, 0, 0, 5, here diagonal elements are equal to 5, remaining elements are zeros, therefore it is also a scalar matrix. Okay, it is also a scalar matrix. Diagonal elements are equal, remaining elements are zeros, then it is a scalar matrix. This scalar matrix is also diagonal matrix. Next, unit matrix or identity matrix. A square matrix in which each diagonal elements is equal to 1 and all other elements are being zeros, remaining elements are zeros, is called a unit matrix or identity matrix. In a square matrix, each diagonal elements are equal to 1 and all other elements being zeros, remaining elements ఏం కావాలి, zeros కావాలి, and diagonal elements are equal to 1 కావాలి, then this matrix is called a unit matrix or identity matrix. In the first example, 1 0 0 1, it is a square matrix and principal diagonal elements are equal to 1, remaining elements are 0. In the second example, 1 0 0 0 1 0 0 0 1, diagonal elements are equal to 1, remaining elements are 0, therefore it is identity. And unit matrix of order n is denoted by in. Suppose for example I2 means I2 by 2 matrix 1 0 0 1, and I3 means 3 by 3 matrix is 1 0 0 0 1 0 0 0 1. Okay, it is the unit matrix or identity matrix. Next, lower triangular matrix. If all the elements above the principal diagonal of a square matrix are 0, it is called a lower triangular matrix. If you take any square matrix, principal diagonal above elements are zeros, all the above elements are zeros, then it is called a lower triangular matrix. Okay, now 1 0 0 2 5 0 7 8 minus 6, it is a principal diagonal above elements are zeros, then it is a lower triangular matrix. Next, upper triangular matrix. If all the elements below the principal diagonal of a square matrix are zeros, then it is called a upper triangular matrix. In the example, it is principal diagonal or diagonal. Below the elements are 0, therefore it is upper triangular. In a second example, it is a principal diagonal, A22, it is A33, okay, below the elements are zeros, therefore it is a upper triangular matrices. Okay, next. Next one, equality of a matrices. Two matrices A comma B are said to be equal. When we said two matrices are equal, if A comma B are same order, means they must be same order lo undali, and each element of A is equal to corresponding element of B. A లో ఉన్న ఎలిమెంట్స్ అన్ని కరస్పాండింగ్ ఎలిమెంట్స్, ఏ పొజిషన్లో ఉన్న ఎలిమెంట్స్ అన్ని ఆ ఎలిమెంట్స్కి ఈక్వల్ అయితే, బిలో ఉన్న ఎలిమెంట్స్కి ఈక్వల్ అయితే, దెన్ వి సే దట్ ద మ్యాట్రిసెస్ ఏ అండ్ బి ఆర్ ఈక్వల్. ఆర్డర్ ఈక్వల్ ఉండాలి, సేమ్ ఆర్డర్, అండ్ ఎలిమెంట్స్ ఆల్సో ఈక్వల్. Then the matrices are said to be equal matrices. Next, operations on matrices. We will discuss operations means addition, subtraction, scalar multiplication, and multiplication of matrices. Okay, now addition. Addition means if A comma B are two matrices of same order, add cheyali ante two matrices ni they must be of same order lo undali. Then their sum A plus B is defined to be the matrix of the same order obtained by adding corresponding elements of A and B. Adding corresponding elements of A and B. A plus B, A comma B same order undali, same order. Then A plus B is defined as adding corresponding elements of A and B. For example, capital A equal to A11, A12, A13, A21, A22, A23, it is a 2 by 3 matrix. Capital B equal to B11, B12, B13, B21, B22, B23. It is also 2 by 3. A is also 2 by 3, B is also 2 by 3. Both are same. Then A plus B is also 2 by 3 matrix. Corresponding elements, we have to add corresponding. A11 plus B11, A12 plus B12, A13 plus B13. A21 plus B21, A22 plus B22, A23 plus B23. Corresponding elements ni add chese vachedi A plus B. Okay. Next, subtraction. A minus B is defined as a matrix whose elements are obtained by subtracting elements of B from the corresponding elements of A. Corresponding elements ni cheyali. A11, A12, A21, A22, it is a 2 by 2 matrix. B is B11, B12, B21, B22, it is also 2 by 2 matrix. Subtraction. A minus B is also 2 by 2 matrix. a11 minus b11, a12 minus b12, corresponding elements subtraction, a12 minus b12, a21 minus b21, a22 minus b22. Okay, that is subtraction of a matrices. Here also if you take minus, it will get minus, 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 minus. Corresponding elements are subtracted, then it is a minus b. If it is added, a plus b. Next, we have last one, multiplication of a matrix by a scalar. Matrix ni scalar to multiply cheyadam. So, if every element of a matrix A multiplied by scalar k, the matrix obtained k times the matrix A and it is denoted by k. Okay, matrix ni k to how to multiply with a scalar k. Suppose A equal to a11, a12, a22, a21, a22. Then ka. Ka means if every element of this matrix is multiplied by k. Ka11, k into a12, k into a21, k into a22. That is a scalar multiplication of a matrix. Means every element of a matrix is multiplied with k. That is a ka. These are the operations. First one is the addition. Addition means they must be two same order and corresponding elements are added. Subtraction means same order, corresponding elements are subtracted. Scalar multiplication means every element is multiplied with k. Okay. Today's class we discussed about definition of a matrix, order of a matrix, and types of a matrices. In that, rectangular matrix, square matrix, row matrix, column matrix, null matrix, diagonal matrix, scalar matrix, unit matrix, upper triangular, lower triangular. Next, equality of a matrices. Next, operations lo addition, subtraction, scalar multiplication. Okay. Thank you. If you have any doubts, send me a message.